Hey everybody, welcome back to our little tutorial here where I'm going to walk through how to do the descriptive statistics table. So the purpose of the descriptive statistics table is to provide summary univariate measures of the variables that you've been collected. So univariate means summary statistics for one variable. So we're going to look at things like mean, median, mode. Well, specifically, it's really going to look at mean and standard deviation for our quantitative variables. And we're going to do some marginal probability and also talk briefly about how you could use it to look at joint probability for our qualitative variables. So to get started, I'm going to share my screen. So that's the purpose of the descriptive statistics table, is to give us those summary measures just at a glance. At this stage in the semester, you should have roughly 10 observations at least. I think I may say up to 10 or 20, but you'll have time to keep filling this out until the full data set is due in is the next assignment after the descriptive statistics assignment. So this is the example from the operationalization assignment. Remind you here, this is our data in tabular format, where each row is a unit. So in this case, our unit of analysis is song. Each column is a variable that measures characteristics of the song. And each cell is the value of the associated unit or observation for that variable. So the twist has a value of 1960 for the variable year. In other words, the twist came out in 1960. This week's one measures how many weeks it was number one on the top 100, and it was, or I think Billboard's top 500, whatever the example was from last time. And we see here that the twist was number one for 3 weeks. It was in the top 3 for 14 weeks. It was in the top 5 for 21 weeks, and it was in the top 10 for 30 weeks. This is whether the song is woman-led or the primary singer is a woman, where it's a dummy variable or a binary variable, where it has a value of 0 if the condition is not met. In other words, it is not woman-led, and a value of 1 for if the condition is met or the song is woman-led primarily. And this song is how pumped or excited that the song made me. It's a subjective rating for how pumped I am about when I listen to the song. I also added another variable here. I think it may have been from before, for generation. So this was the generation that was, I think I said 20 years old when the song first came out. So in 2020, 20 years ago, Gen Z, Gen Z was in their 20s in 2020. The silent generation were in their 20s in 1960. Gen X were in their 20s in 1999. I did it exactly 20 years before. I'm happy to talk more about exactly how I measured this, but I won't go too deep into that. That's more in the thinking behind operationalization. And there's quite a lot of sociology about generations and political science and criminology and how we measure them. And so it's a good socially constructed concept. All right, so I'm in here in our student view. I'm gonna here download our example here. So here's our instructions for what we're going to be doing. And you can follow along with these instructions, as well as these detailed step-by-step instructions and an example table. After I finish this, I'll post the additional example table as well on the sheet here. And this is the rubric. Again, as a reminder, I want to point out that what I'm asking you to do is very challenging. And it may take you a little bit of time to figure out exactly how to do it and making smaller errors. So I want to again remind you that you will be able to continue making revisions on this assignment until the next assignment is due. And the next assignment is your full raw data, where you should have at a minimum 30 observations, or as many observations as you're able to collect or willing to collect. And that's the next assignment due. So you'll be able to continue to revise this descriptive statistics table until that assignment is due. So I want to make another reminder here that this is a good time to continue adding more variables and more observations. It's also a good time, before you gather your full data, to consider using the my population assignment. If your project allows it, take a random sample or a simple random sample. Again, you can use the command that we did in class when we generated the simple random sample for looking at who was the voter who voted for Marcus. You can use that same one since you, in the my population assignment, gave every single potential observation in the population. You assign them a unique identifier. You can use the random command to randomly sample. So I explained how to do that in that other video. I just want to give this as a reminder that if you can do that, I strongly suggest it because it will make your paper later it'll make it a lot easier to justify your sampling technique later, and just lots of benefits. That being said, it's not always possible for every single for every single project to take a simple random sample, but suggest you do and consider adding more variables as well. See here I have one, 2, 3, 4, 5, 6, 7 qualitative variables. Or no, sorry, this is quantitative. 1, 2, 3, 4, 5 quantitative variables, 2 qualitative variables here. So can never hurt to have more. And I'll briefly say why as an example. We'll later in the semester, when we get to bivariate statistics, so in the descriptive statistics table, we're doing univariate statistics or statistics about one of the variables or columns. But later we're going to look at bivariate statistics, which will assess the relationship between two variables. As an example, I'll be able to ask whether songs from different generations make me more or less pumped when I listen to them, or whether songs that are woman-led were more or less likely or lasted for longer or shorter on the top 10. So the more variables you collect, the more bivariate associations or relationships you'll be able to analyze later when we learn about all the different tests that you can use for the different types of combinations. So I'm going to download this template as an Excel file. You can also upload this Excel file directly into Google Sheets by doing file. What did I do? You can do file import. So you can import the table directly into Google Sheets if you prefer to do that, but I'm going to make it in Excel. So here's our template. This looks very similar to the template, and the instructions are in fact identical to when we did this for the different buildings at the College of New Jersey. So I recommend you consider doing that as well. I'm going to save here the copy of the descriptive statistics table, just so we have it. Table songs. All right. So actually, real quick, before I get started here, I want to go over a few other things. I've given much of this feedback already throughout your paper, throughout your assignments, but a few principles for how we want to do this. First, you want all of your variable names to be single strings or successive characters. In other words, there's no spaces. And one thing to especially note with these is you want to not have any spaces at the end of your variable names. That'll give you a headache later on. So for example, if you had a space right there, you want to make sure that you delete it. They're also all lowercase, and they don't have to all be lowercase, but it will make it easier later on, etc. You also want to make sure that your columns and variables are mutually exclusive and exhaustive, especially your qualitative variables. So for example, this generations, every song has only one generation, and every song has a generation. Similarly, make sure there's no spaces at the end of your category names here as well. So there's just a few common notes. Another common one that we ran into is your quantitative variables should be entered only as a numeric value. So one common example was song length. So if we had a variable for length, then we'd either want to measure length in seconds or in minutes. So if you had it set up like this, for example, we'd either want to measure these length in minutes by writing 1.5, 2.5, 3.25, or in seconds. Hopefully I didn't do any embarrassing math right there, but you want to make sure it's singular numeric values. Okay. So to get started here, we're going to want to open up our Posit Cloud or go to Posit Cloud and open up the assignment for final project. I'm going to make a copy so I don't get rid of our example here and name it song example. Now, you can gather some of these descriptive statistics just from using Excel, but I'm going to recommend that you continue using R that you use R to gather these statistics, because you're going to need to submit a replication package, or you're going to submit your script that would allow someone else to recreate your results. So if the way you're recreating your results is just by using Excel, then it's going to be more challenging for you're going to have to go back and add these commands in later. So open up our script. Remember, this is our template script. So we're going to want to save as our script, give it a different name. So I recommend you call it your last name .r or your project name. Well, for later, use your last name. So it'll be your last name .r. Now, especially later, you're going to want to make sure you update all of these different examples, these different notes here, and you're going to add notation throughout your script. Again, notes start with these hashtags and are in green, and this signals to R that you're just talking to yourself. So if I run this note, it doesn't do anything, it just prints it down here. It's just R, I'm talking to myself in green. So songs example, put in today's date, and you'll update this date with whatever the last date it was that you updated the script. And yeah, etc. But you can go through and work on this and continue and update these as you go. So I already give you these, but our first step, remember that R always assumes that we run things in successive order. So before we can run commands down here in the script, we always assume that commands from before are ran. So these commands, this library command is loading these different packages that we're going to use for various purposes throughout the semester, and throughout the semester, we're going to load and we're going to run these to load these packages in. And this command is going to create the object data using the command read delim on the file rawdata.csv. So it's going to look for the file raw_data.csv and then use the command read delimiter to create an object called data. Now, if we run this, we'll see here it says raw data does not exist in our current working directory in Cloud Project. And that's because we come down here, we see we have not uploaded our raw data. So you've already uploaded your raw data here, and some of this is just a reminder and sort of recap on things. But one thing I wanted to make sure I noted here was that after every time you update your data, you'll need to re-upload your CSV file back into your environment, back into your files. So as a reminder of how we could do this from Google Sheets, I'll go to File. Oh, another common thing to keep in mind with this is some folks have like notes or other things on this Excel sheet. And those are fine to keep in your personal Excel sheet, but when you download this as a CSV, you're going to make sure that it only includes rows that are observations and columns that are variables. So we don't want to have any other pieces of information on our data sheet when we download it and upload it into our. We're going to file, download as a CSV or a comma separated values file. I'm going to hit download, and we see it gave us the name songs_example space dash space capital SHEET1.csv. Now we're going to go to our Posit Cloud. If you already have an old version of the file, consider deleting it. So if I wanted to delete this, for example, I'd click this little check mark and press delete. But I don't have an old one, but consider deleting the old one before you upload the new one, just so you don't accidentally confuse yourself on the most updated, up-to-date data. Or consider, even if you don't want to delete it, in case you don't want to lose it, you can just rename it old data. So I could, for example, click this, hit rename. If this was old script, call it old script, or whatever I wanted to call it. We're going to upload, we're going to find our file here in our downloads. Now, again, once we've uploaded here, note that if I try to run this command, it still can't find raw_data.csv in the working directory. And if we look down here, that's because we don't see raw_data.csv. You have to click here and rename this file based on what we're calling it. Now, another thing we could have done is change this to match the data, what the file was called down here. So if I re-upload this old file here, I can change this to be called songs example space dash space SHEET1, like that. And as long as it matches, you're able to upload it. Now I'm going to suggest you just keep it called raw_data.csv, but just as an FYI for why that is the case. Now I also get to show how to delete ones you're not using. So you click on the show it slower. You click on the check mark, press delete, and press yes. All right. Now have an object raw_data.csv. Trying to read raw_data.csv. I'm going to highlight the command, highlight the line, and press run. You see, now the object data is up here in our environment. We see we have a total of 13 observations over 9 variables. And now it looks just like our example here. All right, so now we come down here to our descriptive statistics, and this is where we're going to write our commands to generate our descriptive or summary measures for our variables. I'm not going to do summary statistics for every single variable in this example, just because it'll make the video last a little while, but I'll do a few examples for a quantitative and a qualitative variable. Let's start with a quantitative variable. So we use the command mean to find the mean or the statistical or the mathematical average. Type in the command mean. We go inside the object data. We go inside the object data using the $sign. And then we're going to type in one of our quantitative variables, weeks in the top 10. Now we run this. We see that the average song from this data that we collected was in the top 10 for 28.5 weeks. Now there are a bunch of other commands we've used here, and I'm also going to show some good practice of how to use notation here. Generate summary measure statistics. for weeks in the top 10. Note that I write note that notes are written in substantive terms. In other words, I'm not using a lot. I'm trying to write these in a way that could be understood by someone else who is accessing the script. I can have spaces. I can write narratively. I can make the notes whatever would make the most sense to whoever else was looking at this. So we can use the command SD to get the standard deviation. So the standard deviation for number of weeks in the top 10 is roughly 12. So if the number of weeks in the top 10 was normally distributed, and we could see that by using our histogram. And we can see that it's not normally distributed. It looks like it has a right skew. In other words, there are some songs that are on the top 10 for way longer than other songs. But if it was normally distributed, then we could roughly say that most songs are in the top 10 for about 28.5 weeks. And almost all songs are in the top 10 for some time for between 17 weeks and 39 weeks, roughly, give or take. Again, we got 17 by doing 28 minus 12, and we got by doing 28 plus 12, and oh yeah, 40 weeks. I did the math wrong a second ago. So most are between 16 and 40. Now that interpretation of the standard deviation does assume, or it's only accurate if weeks 10 is normally distributed. So you don't have to do this at this particular stage, but you will need to know about the distribution of your data in later on. So I do recommend looking at the histogram, especially when you go to assess assumptions later. So it's a good idea to take a look at your histogram. And as I ask you to consider also comparing it to your expected histogram, or what you expected the histogram to look like from the in-class activity on central limit theorem. Okay. Histogram. A few other measures we've done summary. We've done a few other ones here as well. So the summary will give us the mean, the median, the inner quartile, the quartiles. So the 25th percentile is 22 minutes or 22 weeks. So 25% of songs were in the top 10 for 22 weeks or less. And 75% of songs were in the top 10 for 22 weeks or more. Ignore the very particulars about whether 22 is in the first quartile or not, but that's the general premise of it. The minimum number of songs, 14. Of all the songs in the data set that we collected, so of all the songs that we looked at here, the song that spent the least time on the top 10 was in there for 14 weeks. The song that spent the most time on the top 10 was there for 57 weeks. We can look at the data also to see which songs these were. And we can do that is by sorting. We sort by clicking. And we can see that of all the songs that we looked at, Debbie Boone's You Light Up My Life was on the top 10 for the shortest period, around 14 weeks. And Blinding Lights by The Weeknd was on the top 10 for the most weeks at 57 weeks. That's a long time. Wow. It's like a whole year. Crazy. All right. So lots of different things you could do here, but let's now show how we're going to convert this to our table. So first, you'll see I have different series of notes and instructions. I'm going to go through this kind of quickly, but I recommend you read through the notes because there's a lot of different contingencies and or little things you have to notice when you're making this table that I'll try to show in the video, but I do highly recommend, in addition to this video, closely reading the instructions. The general premise is I put in green all the cells that you're going to need to change. They shouldn't be green afterwards. In fact, you're going to want your table to look like a professional table by the end of this activity, and certainly by the final project. but I put it in green to show you what you're going to want to be changing. So first, we want to put a substantive variable name. So our variable for weeks in the top 10, weeks in top 10. Notice I can have spaces, I can have capitalization. In fact, I may even want to capitalize this top 10. You want someone should be able to read the variable name and know generally what it means, what it represents. Certainly, they should be able to know what it represents after they read the description. How many weeks did the song spend in the top 10? Or even simpler, number weeks in the top 10. Spend a lot of time making variable names and variable descriptions. This is more of an art than a science, but the general premise is you want them to be as short yet substantive as possible. So someone should be able to read them and know exactly what it means, or very close to exactly what it means, but they also shouldn't have to spend a ton of time reading it. That's what the data section of your paper will be, when you'll describe exactly how you operationalize or measured the variables. So that's when you can say exactly how it calculated the number of weeks the song was in the top 10. So we can come back here, and using our summary command, we can also use, the min max command, all the other commands we've already looked at. I think this one worked here. I think there was a package for it. So min tells the minimum. They'll just return varying first purposes of this summary. Max similarly. Give us the max. Anyway, we want the mean, 28.53. So one common question you may get is, how much do you round for these? Generally, especially for these qualitative examples, as I'll show in a moment, I suggest you round all of the everything to 2 decimal places, so the 100th point. However, this may mean you need to rescale your variable if rounding to the 100th decimal doesn't make sense. Yeah. So, and you also could consider rescaling some of your quantitative variables to make them not be massive numbers in this mean. So as an example, the total number of views on a song may be one that you'd want to measure in millions. So what's another key thing to keep in mind with your description is you want to make this weeks, the unit clear. I'm going to give another example because I don't have year, or I don't have a very large or small number, or a variable who I want to readjust the scale in the in the example here. So let's say instead of number of weeks in the top 10, we wanted to do number of years in the top 10. So let's say in our data here, instead of weeks 5, we had this be year 5. So I'll just show this kind of what this would look like. Year 10, what do we do? Equals F2. There's 52 weeks in a year, something like that. And now we'd have all these values now measure how many years it was in the top 10. So the blinding lights was in the top 10 for 57 weeks, or 1.096 years. So just keep in mind, if you rescale your variables, I recommend you do it directly in your Excel sheet. And you can also do it in R using the example, as we did for the example in class earlier. We could, for example, make a new variable called data years 10 is data weeks 10 divided by 52. And then we could do summary of data years 10. You get these. And these map on pretty neatly. The average years in the top 10 was 0.5488. This average was 28.536. If we take this value divided by 52, we get that same number. All right, so that stuff was a little bit advanced. I'll add it in just so you have the example of a recode. If you come to look at it in the future. Weeks, top 10 to years. Yeah, now you have an example. So we're going to stick with our weeks in the top 10. Our standard deviation, 0.54, or no. $11.997. It's going to round to exactly 12.00. This is a good opportunity to show that we're going to still include the decimal places, the 2 decimal places, even if we don't use all 2. And I'll explain why that a little bit later. But our minimum is 14 weeks. Our maximum is 57 weeks. 14, 57. Now, I'll add one more just to, so I'll show it later. Pumped. First look at the histogram. Get some summary statistics. Interesting here, we see this is not really following normal distribution. This follows a bimodal distribution where there seems to be 2 modes among songs that I get pretty pumped for and songs I get less pumped with. So something to keep in mind when we go to interpret these things. But ideally, this would be normally distributed. And in fact, I planned for it to be normally distributed, but I'll show some examples of what that would mean later. But so, the mean turned out to where we said it was going to be. Remember, we said that the average pumped should be 50. So the mean is 50. The median is close to being 60. The median is actually the mean and median are not too far off. Just the mode that's off, or the most typical value that's not in this middle range. Yeah, so our mean of 50.77. We need our standard deviation. So I did that kind of quickly, but this is a good thing to show. You can copy previous commands you did and just paste it on down there. And then just change the variable. You don't have to memorize any commands in this class. You can always copy and paste things you've done in the past. In fact, don't memorize anything. You'll memorize them over time. So 15.92, or maybe you won't memorize them, and that's fine too. I still look up commands that are embarrassingly simple given my stage in my career, so that's okay. I'll just go see how this all makes me. Simplify it a little bit. Again, you're going to want this descriptive statistics table to fit on a single page at the end of the class. So you want to keep your description short as you can. We'll call it pumped. Maybe I'll even call it subjective pumped to remind myself and remind the reader that measuring how pumped that this song makes me subjectively. Now you can add more rows by clicking on the row, add or insert. To add more rows on the top here for all your quantitative variables. I want to move on to a qualitative variable just so that we can see the example. So we can see that. All right, generate summary statistics for generation. Now remember, it doesn't really make sense to calculate the mean or the statistical average for the generation in which the song was the most popular. Or actually, I want to show how I interpret these pump things. So if we assume that subjective pump was normally distributed, then we could say the average song made me pumped about 50, and most songs I was between 35 pump. I rated between 35 and 65 on how pumped they made me. Almost every song was between 20 and 80 pumped. Probably need a better measure for pumped units. I don't know. I'd have to think about that a little bit more before I wrote the paper. Units of pumped. So, um, summary statistics. Let's do. So similarly, it wouldn't make any sense to say the mean level of generation. In fact, it won't even let us calculate that because we entered them in here as categories. If I type in mean data generation, I'm going to run this. It's going to say the argument is not numerical or logical. Numerical or logical. Logical would be a false positive. We've seen this in class before, but you want to do it for your project. And numeric would be like what pumped was. Remember, that's why we didn't write the units directly into this. So we didn't write 57. This is a good way to time to show this as well. 57 weeks. We didn't write that. So it needs to be all numeric. So, sorry, go back to the Posit Cloud here. So we can't use the mean. What we use to get summary statistics for our qualitative variables is the table command. Now, a couple things to note here when you first type in this table. First off, make sure you don't have any repeating categories. As an example, if you see Gen X 2 times, so if you see Gen X and then this also said Gen X, so they should be the same category, but you're seeing separate counts for them, then that means that you need to go back to your data and there's probably a space or some character in there that shouldn't be there that is differentiating them. Most likely it'll be a space. But anyway, reminder how we read these, how we interpret these. Of all the songs that we collected, 2 were most popular when the boomers were 20, 3 were most popular when Gen X was 20, 2 were most popular when Gen Z was funny, 4 were most popular when millennials were funny, 2 were most popular when the silent generation was 20 years old. So this gives us our table. Now there's other statistics we can use. Again, as a reminder, we don't really want to use histogram. That's not going to allow us to do it because it's not numeric. So my table got deleted. Run our table here. So with our table, now go back to our sheet here, our variable name, and we see here the categories are now indented. So under the variable, the larger variable category for generation, first category is going to be the silent generation. Second one is going to be boomers. Now we can add, now we have more than 4 generations. So we're going to want to right click and hit insert here. And add more columns for Gen X, Gen Z, Gen X, Millennial, and Gen Z. Millennials are also known as Gen Y, but I just preferred to give myself a real name, you know, little personal bias or personal, subjectivity, at least, maybe not bias. Now we have a separate row for each of these categories, and we're going to add descriptions for each. So again, we want this to be very clear what exactly this measures. Songs generation, that's not as clear as what that means. This may be an example of where you'd really want to look at the description to know what the variable measures. Generation, 20 years old. Generation of a 20-year-old when the song was released. Is that accurate? Generation of a 20-year-old when the song was released. It sounds about right. Got periods, punctuation. Song. And silence. Song is from Gen X. Song is from Millennial Generation. I'd probably want to rethink these descriptions. I don't like them that much, but it's not really from Gen Z. It's more just that it was popular with Gen Z, but like might not even have been popular with Gen Z. That's a whole question of operationalization. But yeah, the general point here, you're gonna put descriptions, also indented for each category. Now, what do we put the mean? Silent, we just saw we can't get the mean directly of a qualitative variable. In other words, it wouldn't make sense to say that the average generation was 2.5. Most generations were somewhere between 1 and 8. That doesn't make any sense. So instead, we're going to put in the mean category the proportion of observations that fall into that given category. So if we want to know what proportion of the songs in our list fit into the boomer category, then to do that, we're going to take 2 and divide it by how many songs could have been in the boomer category, or 13. And we got 13 by how many total observations there were. 2 plus 3 plus 4 plus 2 plus 4 plus 2. You can also see it up here. 13 observations. 2 divided by 3 returns 0.15. In other words, of the songs we looked at, 15% were most popular during the boomer generation's coming of age. We do the same thing. These other ones. So 3 is going to be 23. Gen X, Gen Z, and silent. These are not in the order. All right, so X is 23. Boomers is 15. Silent is 15. Millennials is the most common at 31. Z. Few things to note here. To double check your work. If your categories are correctly mutually exclusive and exhaustive, then the sum of all of these proportions should sum to 1. Now, here's the good news, or not good news, but a common thing you may see. Because I rounded each of these, this does not sum exactly to 1. That's okay. In fact, if we were to take each of these different values and add them up, 2, 3 plus. You'd get 1 here. But because we rounded, this is just an example of rounding error, the 0.99. That's okay. But if you're far off from 1, then definitely go back and check your math again. Another thing to keep in mind for something you're going to want in the future, and as you go and plan to collect more data, and you want to know how much data do you need to gather. Good rule of thumb is, you'll see later when we do chi-squared in the 3rd module of the class, one of the assumptions of the chi-squared test is that the expected value in each of the cells is a minimum of 5. I don't expect you to know what that means just yet, but one thing to keep in mind here is that each of these categories should have a pretty substantial number of observations in them if you want to be able to meet that assumption of the chi-squared test. It's hard to me to tell you exactly how much you need. That's you to do so, you would need to do a power analysis, which again, we'll briefly touch on in class shortly, but I don't expect you to do for this project. But you're going to want to, if you're seeing like only a few observations in each of these categories, then you may want to consider either revamping your categories to have to be smaller amounts, or to be having fewer categories, or also consider gathering more data. So in this case, I would say that I definitely need more data to support five. If I was doing this project, I'd probably gather at least 100 songs. And I would do so using a simple random sample. I already talked about that earlier. Okay, so that's now our table here. Now down here, we're going to put our sample size of 13. Remember, this is little n signifying sample size. If we put big N, that would signify population size, or all of the potential songs we could have gathered. Now you'll go through and in this descriptive table, add all of your variables. And by adding more rows and columns, etc. So I'm gonna keep this a little shorter here, just so you don't have to watch me make a giant table here. Oh, but yeah, I'll show how to clean this up in a second. I'll keep it a little shorter, but you're gonna need to, you should build it out all the way. If you have more than 4 variables, I'm gonna suggest you build out the whole table for now, because it'll make it easier to update for later. As you add more data, these numbers here are going to change, but the categories, the variable names, and the description should change a lot less. So it should be fairly quick to update these numbers with the updated information as you add it. All right, now our final step is to update this table and make it look professional. So to make it look professional, we're going to make sure we keep all the lines where they are, get rid of the green, the spacing, get rid of the unneeded characters, maybe consider changing our title, and a few other things. A lot of this is more art than science, but I'll show you how I would do it in this particular example. All right. A few things to note here. Small things here. One, the decimal places line up. So we round it to 2. Some of these, if this was a longer value, then you'd still want to make sure that there was 2 decimal places, so it always lined up here. So in this situation, I didn't have any decimal places for the min and max because all of these variables, none of them had decimal places. But if they did, and there was a min and max that had that decimal places, then we want to make sure we were rounding it consistently. In fact, it's probably just good practice generally to round it out and keep everything to 100th place that you have. Double check the indentations, titles, clarity, make sure that it all prints out well. You practice how you'd move this to a Word document. This is all for later in the semester, but you want to make it look presentable. Make it look presentable. You could try practicing putting it on to a Word document here. And you can play around with it in this as well, but make sure it matches and maps on well. This is something to save yourself a headache later down the line. So I think that right about wraps it in here. Yeah, that's just about what it is. I do ask you to have 20 observations at this point. So all you need to do when you submit is submit a screenshot or a snip of our output and the table. Excuse me. Uh, that's my sign. I need to go wash my hands here, but I should be able to finish this without using my left hand. And you go to File, Save As, save a copy of it. You don't need your table to be in CSV. You could submit this directly as an Excel. Solves. There, so perfect. You can submit it directly as an Excel file, or even paste it into a Word document and paste it. In fact, I'd prefer you don't submit this as a CSV file. I'll accept it either way, but now I'm getting into some of the nitty gritty of this. But yeah, that's basically what you are doing here. So submit this. Yeah, I think that's all it is. You're updating your script, putting more stuff in, and yeah, hope this was helpful and you have a good sense of some of the stuff you're doing. And again, highly want to recommend you keep considering and operationalizing more variables and consider taking a simple random sample. So using your My Population assignment to randomly select observations. And as usual, let me know if you run into any questions. And I look forward to seeing all your amazing, professional, and beautiful tables.